Eventually, it's going to get into the glucose metabolic processes, right? So the glucose metabolic process is indeed super important. So even this monosaccharide, it has pre-processed and then go into the glycolide pathways or glucose metabolic processes, and it can be used as an energy source. Okay. And you may wonder, do I have to memorize all of this? No. So take a message in here. This disaccharide can be digested into the monosaccharide, and these monosaccharide, glucose for sure, but other galactose and fructose in maltose is eventually going to go to the glycolide pathways. They can be utilized. And where this one is happening? Mainly liver. Okay. So by saying that, we can go on to the fructose metabolism. So the fructose is coming from the sucrose, and the fructose can directly go on to the fructose 6-phosphate with a phosphorylation. And we're going to talk about this a little bit more. Okay? And then in this, the fructose metabolism, and the next one is the galactose metabolism. I'm going to introduce a pathological condition. You must be familiar with those pathological conditions. So again, this fructose metabolism happening in the liver for sure, and a little bit in the kidneys and the small intestines. So in the liver, the fructose will be phosphorylated by the fructokinase. So there are two kinases that can make the fructose be phosphorylated. One is fructokinase, the other is the hexokinase. So the fructokinase is mainly expressed in the liver, and the hexokinase can be expressed in the other part of the tissues, so including the muscle and those two things. So later on, you're going to get some ideas. If you're talking about the liver and the kinase, it's very specific, like the fructokinase, galactokinase, glucokinase. So liver can make various types of enzymes. But in the peripheral tissue, it's highly specified. So it's kind of general. Most of the hexoses can be asociated. So hexokinase can do the multiple job. Glucokinase, galactokinase, and glucokinase happening in the liver, but in the peripheral tissue, hexokinase can do handle all the population for the hexoses. So here, again, the muscles, the glucose can become a glucose phosphate, and fructose can be phosphorylated by the hexokinase. So I'm not going to worry about that one much. But we're going to worry about the fructose phosphorylation in the liver. So in the liver, the fructose can be phosphorylated by the fructokinase. Like I said, kinase can catalyze the phosphorylation by using ATP. So if they have energy depletion, so ATP is not available, kinases is not going to work, right? Because there's no source for phosphorylation. And then this fructose 1-phosphate can become the glyceraldehyde and the dihydroxyaldehyde phosphate by the fructose 1-phosphate aldehydes. And then these glyceraldehydes can become a phosphorylation again, glyceraldehyde 3-phosphate. So ATP is being used, and this time the triose kinase do actions of that. And then triose isomerase can be used to make the dihydroxyaldehyde phosphate to the glyceraldehyde 3-phosphate. And then this glyceraldehyde 3-phosphate can be used in some other glucose metabolic processes later on. So this is the kind of middle part. And I really want you to pay attention to the fructokinase and the fructose 1-phosphate aldehydes and these two enzymes. You don't have to memorize all of this, but you need to know which enzymes we discuss this pathological. The first pathological condition I want to talk is the essential fructose urea. So as name implies, fructose can be detected in the urine, right? So that's the problem. So the result, the forms of the deficiency of fructokinase in the liver. So fructokinase is not expressed in the liver. So this is kind of autosomal recessive metabolic disorder. So it's a metabolic disorder. So the patient cannot make a fructokinase. So the fructose cannot be phosphorylated. So the whole fructose can be stay as it is. And then this fructose, liver is really highly perfused organs, which means a lot of vasculature in the liver. So this fructose can go onto the kidney and it can be injected into the urine. So the big problems we have in here, the fructose is the monosaccharide. And then in the urinalysis, we're going to study it later. When you detect the glucose in the urine by using the dipsticks, this fructose can generate a false positive, and then these accumulations of the fructose in the blood and the urine can lead your doctors to the misdiagnosis of diabetes mellitus condition. Okay, that is kind of the problem. Just pose the diabetes mellitus condition if possible. And the hereditary fructose intolerance can be result from the adenylate deficiency conditions. So usually this is the hereditary, this is genetic associated. The symptoms is developing in the infancy, very young, the newborn babies. Baby has kept crying, and then you can see the stomach is blind stomach pains, and diarrhea, and there's some hypoglycemia-like condition can be developed in this patient. Hypoglycemia is associated with this hereditary fructose intolerance. Why? Again, fructose is the monosaccharide, and it is going to be used in making the energies. So if the fructose cannot be processed, and the fructose cannot be used in the metabolic processes, then more glucose is going to be used to fill out the gaps between the normal and this fructose intolerance patient. So as a result, the hypoglycemic conditions can happen. And then if the patient will continue having these problems, and then again, the infancy is the newborn baby, I guess they cannot talk. So if the parents didn't catch that one, and then they didn't bring the babies to the pediatrician doctor, there's no treatment. The fructose intolerance is continued, then it's going to result in a very serious problem, like the hepatomegaly. The liver is going to be huge, and then eventually can go on to the liver cirrhosis, and then liver malfunction. If that happens in the newborn baby, it could cause multiple problems. So it's going to be a very serious condition. And then the next one is the hereditary fructose 1,6-bisphosphatase deficiency. You may didn't see these enzymes in the previous slide because this enzyme is not important in the glycolytic acid. But this one is important in the gluconeogenesis acid, which we didn't talk yet. So the fructose 1,6-bisphosphatase deficiency condition is not going to influence the glycolysis, but in the long-term gluconeogenesis process can be influenced by this and the ACP, from time to time, they make the data profile having this essential fructoseuria condition, and it drive you guys to make a decision, okay, this patient has the diabetes mellitus patient. So again, in this case, you can see the fructose levels goes up, right? And then the fructokinase activity goes down. And then as a result, you can have, the dipstick false positive in the glucose, right? And those so as I promised, I'm going to stop in here, and I'm just starting from here, start with metabolism, because this is really complicated. So page is not gonna correct, so I'm gonna you guys make mistake. And then again, the geography students, I'm gonna set up the Zoom meeting.